Okay, folks, this example, so we have count value 0, 1, 2, and 3. Okay, so what this means that we can represent this using 4 states. So A, B, C, and D. Okay, and then so the top part is the state name, the bottom part is the output. So we could say, and if we translate that into digital number, these are 0, 1, 1, 0, and 1, 1. So this is output. Oh, that's output 0, 0, 0, 1, 1, 0, and 1, 1. Okay, so when UD equal to 0, it counts up. Okay. UD is equal to 1, it counts down. Okay. Okay, this is called a state diagram. Okay, now we have to translate that information into a state table. Okay, state table will have a present state, next state, okay, and output. So so present state, what you do is you write down the total number of states that you have. In this case, A, B, C, D. Okay. At each state, the state A, the output is 0, 0. At state B, the output is 0, 1. At state C, the output is 1, 0. And state D, the output is 1, 1. Okay. So to determine the next state, right, we have an input. The UD input determine what is the next state. So we actually have 2 columns. Okay. At state A, when UD is at state A, right, you have to look at the outgoing edge. When UD is equal to 0, it is going to state B. At state A, right, when UD is equal to, I just realized there's a mistake right here. Okay. At state A, when UD is equal to 1, is going to D. Okay. At state B, when UD is equal to 0, is going to C. When UD is equal to 1, is going to A. At state C, when UD is equal to 0, is going to D. When UD is equal to 1, is going to B. At state D, when UD is equal to 0, is going to A. When UD is equal to 1, is going to C. Okay, so look, A, B, C, D are states, okay? So we need to convert A, B, C, D into some representation that we can use to convert into digital logic. So one way to convert is, convert this is what we call a minimized bit encoding. Okay, minimized bit encoding, because we have 4 states. The minimum number of bits that we could have is 2 bit. Okay, so we can let A equal to 0, 0. B represent as 0, 1. C represent as 1, 0. And D represent as 1, 1. Okay, now we can take the table that we have, present state, next state, and output. Okay, so what we're going to do is we're just going to replace all the A, B, C, D with the encoding that we have. So remember, we have UD 0 and UD 1. Okay, so B is 0, 1, C is 1, 0, D is 1, 1, A is 0, 0. Okay, and D is 1, 1. A is 0, 0, B is 0, 1, C is 1, 0. Okay, so and then we have the output. We will call it, label it this way, F0 and F1. Okay, so and we will label our present state with lowercase and next state using uppercase. Okay, from here, so this is y1, this is y0. Okay, from here we need to determine the logic for y0 for the next state logic. Okay, so look at what we're gonna do is we're gonna use UD as one of our index and the present state as index. Okay, same case here, UD 0 and 1. Okay, so now here is the, for y0 we're going to take this and that. Okay, 1 0 1 0 1 0 1 0. Okay, so you can tell that cap y0 is actually y0 naught. Okay, and this and that. Okay, so is 0 1 1 0 1 0 0 1. Okay, cap y1 is UD exclusive or that. Okay, we have this is because we are using minimized bit encoding, so the number of bits is equivalent to number of flip-flop that we use. So our circuit will actually look like this. This is actually F0 or Y0, cap Y0, Y1 or F1. Okay, and our logic equation tells us that this is equal to that. Okay, and this is clock data Q D Q clock. Okay, this is our up down counter. Okay, hope this helps.